Okay, great. Hello, everybody, and welcome. I'm Claudia Brittenham, Associate Professor of Art History at the University of Chicago and Interim Director of our Center for Latin American Studies. The event today is developed in cooperation with the Tinker Field Research Collaboration. And one of our goals is to think expansively about what field research might mean in this particular moment where our various different kinds of access to the field are limited. And so I'm so glad to be able to present this presentation and conversation with Marcello Canuto, who is director of the Middle American Research Institute and professor of anthropology at Tulane University. He has undertaken archaeological excavations in the Maya area, South America, India, North Africa, and the Northeast US. His research interests in the Maya area have been on the integrative mechanisms the ancient Maya used to build and maintain a socio-politically complex society through both the post-classic and pre-classic periods. He now co-directs a project in the understudied Northwest Petén, Guatemala, where he investigates the construction of social categories and the mechanisms by which complex socio-political organizations were developed and have been maintained. Marcello has also just done a tremendous amount of work with various different kinds of remote sensing and thinking about how that kind of data can be integrated with other sources and available kinds of data. And that's going to be the subject that he will be presenting today.
I'd be interested in hearing a little bit about your how you find yourself kind of at this intersection between art history and archaeology, and how you've navigated that that kind of new field that you are one of the pioneers in.
Oh, thank you so much, Patricia. What a lovely question. So I think most scholars work somehow at the intersection of more than one discipline, or at least, for many people, work at the intersection of a field of area studies, which has certain linguistic competences and certain bibliography in common, as well as in a discipline that has another methodological bibliography that unites it. And one of the things that feels particularly important to me as an art historian who works in a largely archaeological field is that it's really important to understand the kind of data that are generated by archaeological excavations. And so, a lot of my training in graduate school was actually in in classes in the archaeology department. Marcello was one of my professors once upon a time. And it's important to be able to read an excavation report, read a site plan, really think about what are the ways that archaeological data is generated, and what are the at the same time as I've done a lot of thinking about sort of what are the questions that an archaeologist might ask of a data set versus what are the questions that an art historian might ask of the same data set. And so my dissertation, for example, was a kind of archival archaeology. I went back into the excavation reports for the city of Cacaxtla in central Mexico, looking and thinking about what data was available about the images from the site that the archaeologist might have not paid so much attention to, because they were much more interested in larger questions about social organization. And and so I was able to find, for example, that each of the paintings at Cacaxtla had been intentionally buried, and this was noted by the archaeologists for the first painting that they discovered. And then every other painting you look, and and you look at the stratigraphic diagrams, and everyone says tierra muy fina, tierra cernida, so sifted earth, very fine earth. And so all of a sudden I can reconstruct evidence for practice and then think about what that practice means in the context of painting and in the context of other kinds of ways that we know images were treated in Mesoamerica, simply from reading the excavation reports. I think it's really important for art historians to be numerate. I think it's really important for archaeologists to be numerate. I think this is one of the skills that we make it okay for people to sort of wave their hands and say, oh, numbers are hard. I don't really do numbers. But I really think it's important for everybody. I mean, like every informed citizen to understand basically kind of how statistics work. And to be able, so then, whether you're looking at like vaccine efficacy data, or you're looking at, claims about ceramic distribution, you are able to form your own opinion and sort of, eyeball the data and, decide how you feel about the data and then how you feel about how the data is being reported. the data are being reported. I am on the wrong side of the data plural singular divide in the humanities, and I'm always embarrassed. So that's, but I think it's important in every field to think about the adjacent fields and to sort of really, develop a kind of literacy in those adjacent fields, so that you're not always judging what's happening in those fields by the standard of your own field. And so that you sort of cultivate your aesthetic sense or your judgment of like what is an effective argument in art history versus what is an effective argument in anthropology. Because an art historian and an anthropologist would take the same data and make really different kinds of conclusions from it, and also present their data in really different ways. And it's not necessarily that one is better than the other, right? We are all describing the same elephant in really imperfect ways. And so, cultivating, but also reading widely, I think is particularly important. I would love to have a sense, and I think Mesoamerican studies is a place in which that dialogue goes in both directions, that the archaeologists read the art historians and the art historians read the archaeologists. But I also have to say that I feel like there's so many places where something really interesting in my thinking has been shaken loose by reading something outside of my immediate area of expertise. That's, the book I'm just finishing writing right now, which is on the visibility of ancient Mesoamerican sculpture. It comes out of an offhand comment in an article on the cave paintings of Dunhuang in China. And so you don't always find exactly the same model somewhere else, but the idea of a question or the idea of a method or an approach, or you read something and you're like, whoa, that would not play out so in the same way in this field that I know so well. That can be so generative. So the other thing I really encourage is for people to read super widely as well as super deeply within a particular field.
Without further ado, let me give you a little bit of a background here. When we were talking about all of this, this presentation, we were sort of thinking about what in this world that we're living in and how we're trying to make sense of and do our research in this type of world where our mobility has been so reduced. It sort of came up that it would be an interesting way of thinking about field work without having to do field work, necessarily going into the field, and what does that mean? And obviously there's been a lot of this kind of question in archaeology, which is such a strongly focused discipline, strongly focused in going to the field, right? It's become almost it's just a part of what we do. So this presentation is a little bit of what we could do with research, not having to actually physically move, but what does that mean? Where are we going with all of this? And so we'll hopefully have some time still after all of this to discuss this. Okay, so let me start off by just briefly, because I know not all of you are archaeologists, though I'm happy to proselytize for my discipline as well. Let me just talk quickly what it is that we do and what I do and what it is, how that relates to the topic of today. Archaeology, of course, is a discipline that deals with the past. It's a vast topic. It's a vast kind of world that we think in different time scales, hundreds of thousands of years, millions of years, centuries, millennia, centuries, and even decades, and sometimes even down to the 1 year, depending on what period of time we're working in. And that's actually something, if anyone takes an archaeology class, you'll notice introduction to archaeology. And initially, the time periods are in the hundreds of thousands of years, and then by the end, you might be dealing with months, days, and hours, right? So the scale of time is one thing that we deal with. So what is human history? I'm not going to go through all of that, obviously, but much of archaeology deals with what is essentially human experience on this planet, 98% of which was in what we call nomadic or hunter-gatherer societies. Some really fascinating new work on cave paintings and so forth that just came out recently regarding how humans might have gotten to do this and why they were doing it. But at some point in human history, at a very interesting point, people debate, because in archaeology, everybody debates everything, but about the last 10,000 years, people began to predominantly become sedentary. And by sedentary, we mean living in small towns, villages, and so forth. And thereby for archaeology, this is boom times for us because they start leaving things behind for us to find: buildings, houses, artifacts, garbage, all the kinds of things that you think about as making up the material world. And we love that kind of stuff. So when humans start becoming sedentary, they accumulate things. Think about how many times you've moved from one house to another, and when you move, you end up throwing out as much as you move things because you just have accumulated things in your home. That's great. Archaeology loves that. Keep accumulating. We love to have that kind of stuff. It gives us things to look at in the future. But this kind of work, it creates this wonderful data set for us to begin to investigate. Now, where this then begins to be a question in archaeology that is not evenly studied or evenly distributed in terms of what we can say is, of course, the question of preservation. Where do things preserve and where do they not? What things can we see and what things can we not see? And obviously, arid environments are wonderful environments for the preservation of materials of all kinds. Arid desert environments where you can see things on the surface and then they preserve under the ground. And that's, in fact, if you look at any textbook in archaeology, the kind of traditional places, and maybe perhaps if you haven't done much archaeology in your life, this is something that you know. What are these the great old civilizations? Egypt, Mesopotamia, maybe you'll know the Indus Valley, but certainly you'll see Mesopotamia and the writings, cuneiform, and so forth, all these settlements that developed in these areas that are arid, right? And not too many trees getting in the way. And of course, Egypt went the opposite in terms of familiarity. But there are lots of other places around the world where people settled and built and then created these very large and complex societies, right? And of course, one of the things that we look at, one of the kind of iconic elements that we look at are cities, how people live in close quarters. Famous examples, of course, are Rome. How do they, and as anyone knows, human settlement doesn't look the same. In the United States, you can go from one human settlement that is, let's say, Boston, to another human settlement that's, say, Phoenix, and they're very different cities. They're very different settlements. The way humans distribute themselves along the landscape it is the result and consequence of both historical and technological questions and all sorts of other functional and sociological questions that are all quite complex. But those kinds of questions are what fascinate us as archaeologists. We need these things to be preserved, to be visible and preserved, and those two character variables are vary according throughout the world. So you might have a place that's highly dense, like Rome. We know of examples of other somewhat fantastical but recreated cities from Mesoamerica, from the New World, that are different in their organization, built on lakes or on islands in lakes, and then reclaiming water or waterlogged areas for agricultural production and so forth, but creating these very complex cities and gardens, cities and fields, rather than a city and then fields outside, right? These different models for how people lived on the landscape. This is becoming more and more part of our archaeological toolkit for understanding ancient society. So how people are organized and distributed on the landscape from the moment they're sedentary to today is a fascinating question, right? We have one of these. This is sort of an idealized model that I'm showing here of an ancient Maya city, which is a combination of temples, of residences of more elite individuals, smaller homes, gardens, fields, outfields, and so forth. This kind of an interesting mosaic that we have termed in the Maya world the garden city, a city filled with people's own horticultural-based spaces where they produce certain foods, and outfields where they produce maybe their staple crops. But these are different from, let's say, the city that I just showed you, that's Rome, let's say, which is more the urban style that we come accustomed to. There are all sorts of models of how humans settle in the landscape. This is an example, a kind of a model version of perhaps an Amazonian village, and how it was connected to other Amazonian villages through connected roads and agricultural outfields and so forth. What's important to understand is that all of these all of these civilizations throughout the world modified their environments because they needed to live on those environments and make them productive. And so what we see today and how we see those environments today is not necessarily how they might have been back then. Yet we encounter, because of this, all sorts of interesting challenges. So this is an example of very basic, what is settlement archaeology? What is that we do? We look at the way people are settled along the landscape, and we start thinking about what kind of society produced them, what is their organization, and how is that interesting and comparatively so, right? So these different types, of course, these are idealized types. I'm putting it in very simplistic terms, but this is the kind of stuff that we do when we talk about settlement archaeology. Now, what happens if your environment isn't the arid Mesopotamia, right? We as Mayanists, as I'm a Mayanist, I work in the Maya area. I'm sorry, I forgot to mention that. I'll discuss that in a moment. You know, we're very jealous for a long time of these Egyptologists who could we thought in their pajamas, look at Google Earth and find a site. Oh my goodness, I looked at a picture, a new high resolution image of Egypt, and voila, there was a site in the desert. Well, when you work in areas that are heavily covered by heavy and thick vegetation, tropical environments around the world, not just in the Maya region, but in Southeast Asia and the Amazon, in certain parts of Africa and so forth, what we see is this. Now, in this particular case, there's been a clearing of it for this particular touristic site in Southeast Asia, but this is, like anything, one infinitesimally small part of this massive settlement that is found in Southeast Asia. But if your environment looks like this, how do you know what's underneath there, right? It is a Western conceit that these areas are uninhabitable and thereby empty, or have always been so, when in fact they could very well have been teeming with cities and populations of different kinds, organized in very different ways at different times throughout history. If there's one thing that I've learned in my study of these kinds of questions, there's no such thing as a pristine forest. There's no such thing as a place on the world that hasn't been in some way impacted at some point in the last 10,000 years by humans. Things may look pristine. You know, I lived in Connecticut for 10 years, and Connecticut was deforested in the 19th century, and now it looks like a beautiful, you know, continuous suburb wood, because nobody's farming there anymore. Things can get reforested and look not the way they used to be. And of course, a place where I've worked for nearly more than 30 years now in the Maya region. This is, I generally show another picture that shows a site called Tikal that, for reference sake, is the, you know, rebel base of Star Wars, but this one was a nicer quality picture. So this, you know, this beautiful image of a nice forest around a Maya temple that rises 30-40 meters up. And you can see this because it's a touristic site, so they've cleared it, but everything else around here would have been covered by houses and settlements of different kind, invisible unless you're actually walking on the ground. And even if you're walking on the ground, you can only see so much. So what happens if you're in this kind of environment? And what do you study? Well, if we look at the Maya region that we're looking at, we're studying, this is the area, generally speaking, and I'll highlight it, that we're discussing, that has been, until in certain parts have only recently been deforested. But basically this entire region was covered by a forest for the majority of the last 100 years. There's still very large sections of it that are entirely covered. The very dark green color here is basically primary forest. But we also know from people going into and working on the ground in these regions that there are lots of sites, there are lots of large buildings. Not every building is accounted for, but you have this distribution that does not conform to where the forest is. In other words, the forest today is overlying a lot of places that we still haven't explored fully. We might know that we vaguely know that they exist in some form or another. All the red dots in this particular map are very large sites that have texts writing about themselves in their own history. So it gives you a sense of they're widely distributed across this region. We also know from research that these are mega sites, large, big, monumental buildings within the jungle, right? That are entirely covered over by vegetation today. This is, of course, a reconstruction or an artistic reconstruction. These are some of the larger and high and more voluminous pyramids in the Maya region. And sometimes you can see them. The forest can't cover certain things. Trees generally don't grow in a straight line, but all of you can probably appreciate this linear feature across what is otherwise an uninterrupted forest. That's likely an example of a causeway or a raised road that has differential humidity, and therefore different kinds of vegetation grows on either side of it rather than on top of it, right? So the vegetation has given us clues, even in areas where we don't go or can't go or haven't been able to research fully. We know that there are things of monumental size in crisscrossing this entire region. And because of this, we know that there must have been large populations, people working in complex organization, hierarchical, and also in many ways laterally, hierarchically, working and collaborating in these regions for hundreds of years, right? So how do we do this? And this goes beyond just buildings. It goes into things such as economic organization and exchange of goods. We know that things were coming from certain parts of the region and crisscrossing. Jade, for instance, is a type of material that's found throughout the region, but only has one source. And so we know that it must have come from that source and be distributed throughout the entire region. So commerce was very developed and complex. Buildings, we also know politically, and this is just a simple, it's a text that gives a history of one political dynasty in the region that according to its own records lasted for centuries in this region. Right? And so we have this very long-standing dynastic and political history, a complex regional economic system. We have these monumental constructions, all within an area that is in some ways hard to study. Now, this has been known for decades. The very first archaeologists who worked in this region appreciated this. And they even called in when in the 1920s, in the Roaring 20s, they even called in Charles Lindbergh. I don't know if it was fresh off or just before his trip to Paris. I think it was after that, because it was a known quantity. So after he had made his first transatlantic flight, they called him in to, hey, Charles or Chucky or something. They must have called him some kind of cute nickname at the time. Why don't we fly over the Maya region and take a look at what we got to see? And they got to see these big hills. These are not hills that you see in this picture. These are big, large, monumental structures. Platforms with temples on top. And they realized very quickly that this was covering the entire region, but they would need to know more. They would need to find other technology to actually penetrate through the forest. When the first investigators came, it was prior to any kind of discussion about preservation. They simply decided, you know what, let's cut the forest around the big temples because we need to see what these big temples look like. They were choking these buildings is how they thought of it. And they essentially cleared large tracts of forest around these massive temples. Now, these are 30, 40, 50, actually 60, 70 meter high buildings. So this is not a mean feat to clear these off, nor is it a mean feat for the forest to have covered them in the first place. This is, it was a pretty comprehensive carpeting of the Maya architecture. You can even see here one building that's sort of popping out, but it's still covered entirely by vegetation and its crest. So this is the kind of massive monumental clearing work that needed to be done just to see nearby these large buildings. Can you imagine all the small buildings and all the smaller houses that made up the society? It would have been invisible. And the technology for mapping was what you see here, right? This simple stuff that you might have seen in the last 10, 20 years along the side of a highway, a tripod, a transit, or a transect, depending on a theodolite, depending on the time period, and some kind of stadia rod and some kind of point man that would be taking a point, moving, taking another point, and so forth, and covering the area with points, one after the other after the other. So a kind of basic technology in a relatively low-tech technology in a relatively low-tech environment. This hasn't changed much, right? These are pictures of the last 10, 15 years or 20 years. This is actually this young man here was on my project, and along the way one day in mapping, he found a small little crocodile or a little alligator, a crocodile on his route. He was nearly dying because he was trying to get to water, so it was pretty safe. we brought him into camp and then put him in the water afterwards, and he survived. His name is Pancho. He's huge now. But this kind of mapping, the color photos here tell you that this is just in the last 10 years. Not much different. And you can see things, but you can only see things up to a certain point, right? There's a limit to what you can see. This is me here in what is a little small corridor of clearing in the forest. And I don't know if you can see this, but this is actually a gas-powered leaf blower. And I always thought of leaf blowing as a gardening kind of tool, and I didn't quite understand why you would have leaf blowers in the jungle. It seemed sort of pointless. But then I learned later that these were fire breaks, and this is how you make sure that the undergrowth doesn't you create fire breaks by removing the undergrowth that is what actually burns. So these folks were clearing out some parts of the jungle so that fires wouldn't extend beyond a certain point if they had to come. But this is the kind of, you can see here, you don't see very much in and around yourself, right? So when archaeology began to get involved or interested in beyond the monumental, beyond the temple in the Maya region, scholars devised these strategies to travel through the jungle. And this is sort of an area, this is a very large site, and then the region that it was mapped is in gray. And then these long, thin corridors here, they're called transects, in which people would survey. And this is a picture of these folks in the 60s, very famous archaeologists, taking a breather. This is pre-anti-cigarette, and they're just taking a smoke and taking a breather here while they were basically trundling through the jungle, looking for evidence of people's houses within these very limited spaces because they couldn't really clear beyond a certain amount. So these kind of strategies were all we had. Because it looks like this. Now, in modern technology, you'd say, okay, fine, then now satellites. This was right before some of the technology we applied. This is one of the highest resolution satellite images of a site, the site where I work. And it's a beautiful image of the jungle, right? A beautiful image of trees. So before, maybe you could see just hazy green. Now you can see perhaps even leaves off of trees, but you still just see trees. Right? So obviously we were, as archaeologists, concerned about this. And I put this together for something else, but I thought it was sort of an interesting point to bring up. In over 100 years of research in the Maya region, all the colored areas here, colored by different countries, so Belize, Guatemala, and Mexico, all of the colored splotches here are the areas that we were able to map, that we were able to actually walk and map and see what was lying underneath the trees, right? And it amounts, in 100 years, it amounts to about 570 square kilometers. Let's just say the region that we're looking at here, just in this map, measures something like 90 to 100,000 square kilometers. So we're not even talking, 1% would be 1,000 square kilometers. We were about 0.5% of the region that we're studying is what we had mapped over 100 years. At that rate, you know, maybe by the year 3000, we would have it mapped, right? So what's the solution, or how do we understand, how do we get to understanding how this society was organized along on the landscape in this environment? Well, we can wait for inevitable human activity to cut away at the forest and basically turn it into a pasture land, in which case then we'll be able to see things on the ground or even from satellite imagery, which is an ecological disaster that nobody wants. Here is the rebel base from Tikal, and you can see that this was a problem that archaeologists recognize, right? Coping with the complexities of the floral environments in an area of minimal modern accessibility has strained logistics, budgets, and tempers, and has proven a green hell. And as an aspect of doing archaeology in the Maya region. Well, along came LiDAR. And this was a technology that was developed most likely by the military. We won't explain necessarily why, several decades ago, that is able to actually penetrate the jungle. Now, what does that mean? What it means is that it shoots a series of lasers. It's a light sensor, so the laser. It shoots a series of lasers at very, very pinpoint both accuracy and frequency. And if anyone's been in a jungle or in any forest, no matter how thick, if you lie on the ground and look up during the middle of the day, you will still see little points of light that break through, because it is not entirely covered by the leaves. There are areas in which little points of light from the sky, from the sun, can actually penetrate. This LiDAR sensor that is flown in a little plane shoots so many of these laser beams, if you will, laser beams from the sensor at any given moment and on any one spot, that some of them, a small percentage, but some of them hit the ground. They manage to find the little hole that is in between leaves and hit the ground and bounce back. And if they bounce back, then the sensor can tell how much time it took and then get a measurement, right? And so you can see here, here's the plane flying over. Most of the beams will be reflected by the top of the canopy. A next big chunk will be reflected by usually the second or the lower canopy, and then a very small, up to 2-3% of them will hit the actual ground. Now, 2-3% doesn't sound like a lot, but if you're shooting billions of points, 2 or 3% of a billion points is more than any map I've ever made. It will give you more points than any map that I will ever make. So what does it do? It gives you this. It gives you a map of the canopy, but then you can begin to digitally deforest it, right? And you can say, okay, let me classify all the trees, because it's created a three-dimensional point cloud, as we call it, of trees, top of trees, middle of trees, and ground. And you can classify it. Let's put all the trees that are high. Now let's take out all the trees that are 30 meters high. Now let's take out all the trees that are 20 meters high. Let's take out all the trees that are less than 10 meters. And now we've got the ground. We have digitally deforested this particular area, and underneath we can see a structure, another structure, a long range, what we call a range structure, platform. And even here, you can see this little divot here. You can even see where someone has, in this case, looted, where someone excavated illegally and left it open and created this kind of dimple, this kind of depression inside the building, right? So that's what, so you go from this, which is what a satellite picture would have shown digitally, you remove it, and voila, you get the actual material, you get to see what the ground would have looked like. So now with LiDAR, these 570 or so square kilometers have been supplemented by, in this particular case, one research effort in Guatemala in 2016 by the Pacunam LiDAR Initiative Foundation in Guatemala, covered 2,000 or so square kilometers in one year. So it quadrupled almost what had been done in 90 years was done in essentially, 1 month of LiDAR survey. Problem is, it's a lot of data. We're awash in it, and so it's a massive project that involves collaboration with lots of different universities and lots of different institutions and scholars who are coming together to try to make sense of all of these data. And of course, it requires a lot of data crunching and good computers to do this stuff, right? So it's not for free, right? In the sense that there are other things that need to be done with it. But it produces these kinds of things, right? It produces these three-dimensional maps or you can produce three-dimensional maps from these data of a Maya site. This isn't some kind of hocus-pocusy 3D application that we had to think about and put all the points in carefully. This is just extruding the surface map that we got from all of these points and making it look a little 3D-ish to get all the buildings of this massive center, right? With and this is an area that is otherwise covered with trees. So what do we do with this data, right? Okay, great. So it creates these wonderful 3D maps. Well, we analyze these data and we try to, we create what are called visualizations of the terrain. And these different visualizations, usually what they try to do is accentuate some feature that should be human. It's not a natural feature, something linear, something oval, something that's concave, something that's convex, right? We have all these different visualizations and you can see some of them, you can see things that are a little bit better, a little bit more sharply than others, but essentially these are 4 different visualizations of the exact same image and you can put them all together, and you begin to see things that you might not see in one, but you see in the other. For instance, in this one, you see this nice little obvious big feature here, but in this one, you start to see these other smaller features, and maybe you can see them here. But in this one, they become very clear. And these are little buildings, right, where people lived. So you can actually see small little buildings that are likely to have been the residences of people living nearby a larger site. And this long linear feature here, visible here, is probably a kind of causeway, a kind of road, like the one I showed earlier that was covered by trees. Well, this one is being shown in this LiDAR data that we're looking at, right? And there's probably another one. There's something going on here that's also a linear feature right here. So you can see all of these wonderful features on the ground, and then it's your job as an archaeologist to digitize them, to recognize them, define them, identify them, and try to draw them. So you start from this, what we call a model of the terrain, right? That's given to us. We process it through different kinds of visualizations to let us see what's on that terrain that we think is human-made. And then we process them, we draw them, and we create a map, right? This process here that covers whatever this is, 400, probably 3 or 4 square kilometers, without LiDAR would have taken maybe 8 to 10 years to do this amount of area, right? Manually walk it, map it, and so forth. This took a year, even less, right? And it's not only this that they did, that much larger area, but it's just to give an example of the scale. So what can you do with this kind of data? Well, one of the things that we started looking at was, let's just put a point on every single little building that we see, right? Whether it's a temple or a small structure, let's just put a point on it, right? And we came up with this wonderful, I think, image that's very evocative to me. Of course, you can see the dots kind of they're limited because we didn't cover the entire region. We just covered big blocks of it. But this was trying to kind of emulate what would be the Peten at 30,000 feet at nighttime, right? If like you're flying in the middle of the night and you're flying over a city or a settlement, you see the lights down below, and you can see how our society is organized rectilinearly, or if an older city, not so much, and so forth. You can sort of see how the world, how humans have distributed themselves on the landscape. And this was sort of in our attempt to show this. You can see how densely certain areas are populated here as well, how less densely they're populated in some others. Here's a very dense spot, and then some areas that are very lightly populated, right? This is a nice big difference across. Like if you fly across the nation in the middle of the night, you'll see that over and over again, places that are dense, places that are empty, right? One of the things, for instance, that has been happening in the world of big data, for instance, this is a recent project by Microsoft to provide a map of every building in the United States. Now we can do this for ancient societies in places like my region that were covered by, that are covered today by all of these forests. So for instance, we did this as a study of population, and we looked at every building in Louisiana, right? So here is New Orleans, each building is a red dot. And of course, New Orleans is very dense, and then Baton Rouge and so forth, and other cities. But areas that are not, that are lightly populated and so forth. And then you can compare it to things like the census data. Where do people live, right? And compare houses, density of houses with density of settlement, right? And obviously those things kind of go hand in hand. So when you have buildings, you can talk about people. And when you talk about people, you can talk about how many or suggest how many. And then you have a question of scale. Is it 100 people? Is it 1,000 people? Is it 10,000? Is it 1 million? Is it 10 million? So forth. That helps, right? If someone were to ask me what kind of society are you talking about? Well, one important aspect and basic element is how many people are we talking about, right? A society of 100 is not going to run the same way as a society of 1 million, right? But that requires this kind of data and complex analysis. So if we look at this region here, for instance, this larger region, we estimate now that this area where the central Maya were is somewhere between 4 and 7 million people. It's a big number. We're extrapolating from these large data sets of LiDAR that we have, but it gives you a sense of, okay, that's in this area, right? And what's fascinating is that this area today has fewer people than that. Actually, this area has had fewer people than that since 900 AD. There was an apex of cultural and demographic development in this region, and it still hasn't recovered. So when we do this kind of study, we can take a look at individual structures like this, or we can put them together to think about densities, how many buildings are there? And you can start to create maps that show one type of city versus another, versus another, versus another. Think about, as I said, Boston versus Phoenix, Houston versus New York, right? Very different cities, organized. They're all cities. They're all part of our modern day culture, but they're built in different times for different purposes, and they're organized in different ways. We can start to look at this at a scale that would have been impossible 20 years ago, not even 20, 10 years ago. And that's really a fascinating kind of turn of events in archaeology. More locally, we can look at a landscape and not just find every structure, but find every feature that involves construction, like a terrace, like a drain, a causeway, a wall, a road, a street, whatever, all the things that aren't just buildings. And when we do this landscape that's sort of green and yellow in the background, covered by buildings that are red, roads that are yellow, blue that are drains and terraces, you see that it's an anthropogenic landscape. They have impacted it in very, very complex and irreversible ways. So that what we're looking at is not a pristine forest, but a forest that's grown over a landscape that was entirely inhabited and entirely modified for human existence. Something else that we can do, for instance, is something like this is where I work. We can take the terrain, the actual ground that we, the data that we have. We can classify it in different ways: high, low ground, ground that drains, ground that doesn't drain, etc. All these different categories, and then plop on top of that where buildings are. You see these little black dots, right? You get a little close up, and when you get a close up like this, you can see, wow, this terrain that's yellow seems to have all the buildings. See all these little buildings, right? And the terrain that's brown seems not to have any buildings, right? So suddenly we have an interesting pattern. So as I was saying, basically we are in this kind of environment now with all of this kind of data. We can look at broad regional data. We can think about populations at a regional scale. We can think about how at a smaller scale, we think about how a city or a group of a large settlement modifies its landscape. We can also think more broadly as to how people lived on the landscape, what areas they chose to live in, why they would have chosen to build on certain places like this yellow area and not this brown area, right? We can go into discussions about that in another moment. But these are the kinds of questions. Now, this is not value free or value neutral, I should say. There are concerns about what big data does and how that impacts what we do as archaeologists, right? It is simply at an analytical level. There's this concern across the social sciences that big data will lead to a love of correlation, but a lack of thinking about causation, right? As long as you just, basically it's the, throw everything against the wall and see what sticks kind of thing. Oh, look, this is related to that. Paper on the fact that, shoe size is related to the color of someone's hair in some random set of data sets that are put all these things together, right? And then you might realize that these are just spurious, or correlation is just one aspect of what we do. And moreover, data in some ways of understanding, or epistemological understanding of the discipline of archaeology, is not just there given, it is also made. It is also understanding what is data. And so there's this going up this ladder of inference and then back down, that suddenly we can go back and look at the LiDAR data and it doesn't just reveal itself to us. Suddenly we see things in it that we never understood were data, because we have begun to think and process and interpret and then figure out things that are missing and so forth. So big data is not an answer. It's a new tool that is really fascinating and changing a lot of things, but we have to approach it as something that will have to be absorbed and, of course, understood in the context of what we already know. There's a secondary aspect to it too, which I think is also very important. And this was discussed by an archaeologist who works in South America recently, about the how are we harnessing all of this, but also what it does to our discipline, which is, as I said, started off, is an in the field discipline, usually meaning that we as archaeologists forge relationships with people in our field. It's rare to work in an environment that's entirely devoid of any human settlement. And more often than not, we're also forging relationships with people working, collaborating, and so forth, but also people who have been living in these areas, whether at the site or nearby in nearby village. We often live with them in the sense that we live in their villages or live in their towns. We create all these correlative type of relationships. And the big eye in the sky, much like has been discussed with the kind of the militarized version of that in terms of drones and so forth, what are we doing to the discipline if we see things from the sky and not have that? A lot of people said methodologically we need boots on the ground, which I don't like as a concept for all whole sorts of reasons. But what I'd rather say is we need people there, right? Rather than just boots on the ground. People talk, people interact, people understand. We also, part of our goal is to interact and learn from people who are there, and also try to give back what we have learned to them that might be of interest and of use to them. And of course, so big data of this kind, to me, is just a way of enriching what we know. I'd much rather have LiDAR and not bumble and stumble my way across the landscape and then pretend like I always knew that I was going to find this site that I only found because I was just too tired to walk, and I just sat down and someone said, you're sitting on a big building. Rather have that data, but also still be able to use it in a way that is in fact useful in many ways. And of course, in the end, there's the question, this is not expensive. This is not cheap. This is an expensive technology for the time being. So questions of accessibility and questions of who has these data, who can use them, where can they be stored, and so forth, are all part and parcel of a new kind of world that we're living in, that is exciting for all its technological breakthroughs, but brings up a whole series of new challenges that I think we'll have to discuss over a long period of time. That's it. I made it through without, well, with 2 power outages. Maybe we'll have a third. But anyway, I hope that was of interest to folks.
Wonderful. Thank you so much, Marcello. I know some people are going to have to go, just given the way the timing has worked out, but I do think we have time and perhaps interest in a brief discussion. If people want to just raise their hands, and Marcello, if you want to stop sharing your screen so that we can see each other's faces a little bit more effectively.
Let me do that. Let me find the stop share. Here we go. Okay.
Excellent. Right. So Courtney, I see that you've got your hand up. Go ahead.
Hi, Marcello. It's great to see you here. And it's the first time I've actually heard you talk about your research, so it's really exciting. I have a lot of questions, but I guess the main one I'm going to ask, or I'm curious about, is how this has changed your approach to fieldwork in terms of ground truthing. So now you've got this technology. So, before the fieldwork was your basis, and now you are using it maybe supplementary. I don't know. I'm curious, just like what that means for you and your.
It's a great question. The way it has effectively changed what I do in the field is it's rendered me much more efficient, right? Rather than going and using the field time as the primary exploratory time and setting out, okay, I will go here, here, and here because I want to investigate what's here, and what's here. Now we have an idea of what should be there, as long as it's covered by these data, and we're much more efficient. Instead of actually taking, let's say, I don't know, throw out a time, 2 weeks to go to those 3 places, it actually takes a lot less because we know what we're going to do and see. And actually, it has expanded what we can see and investigate, because we aren't striking out in the ways that we were before. We have a much better sense of where we're going. So it's made us much more efficient in that sense. So to a certain extent, it doesn't reduce the field time; it just renders it much more efficient, especially in the context where I work. Right, and that's something that's invaluable to us, because every day there is an expensive day, and so the more we can do, or the less we can not waste, but not have a successful day doing data gathering as we can is a good one. I hope that makes sense.
Yeah, just a general question. I'm wondering if Marcello or even you, Claudia, can talk about maybe the application of these research methods to disciplines outside of, you know, archaeological or environmental sciences. Let's say for, you know, other social sciences like political science, history, literature, culture. How might this be deployed in other research areas?
I'll start, and then Claudia, if you want, you can piggyback on anything I might say. Well, I would say that one of the things that these kinds of data, these kinds of spatial data provide us, I mean, they're applicable in 100 different ways, right? Specifically, for instance, these LiDAR data, this is just this particular technology. As I said, you might have remembered, I said about 2% of it is what hits the ground. The other 98% is all data about the flora, right? The vegetation. So you can then get, for instance, you can calculate you could calculate the biomass that covers a certain area. So if you wanted to do a survey of how much carbon is sequestered in a region, right, you could actually get a very accurate estimation of that in using these data. A geologist can look at these data and the terrain aspect of it with a degree of precision that is unparalleled up to this point. So there are multiple applications of this particular data, but the broader point is that what we could do is correlate things that were difficult to collect before, right? And so even between archaeology and forest conservation or forest ecology, you could even look at where you know there are now sites, and you can also look at what the data is telling you about the flora that's there, and start to make some interesting correlations that you might not have seen before. So that element is very important. But then it puts us in a comparative scale with, you know, maybe it's a little too far ahead for the moment still, but, you know, we could think about, you've got all these buildings, you've got all this architecture, you know, now we can start looking comparatively across different societies and maybe get involved in questions of historical urbanism versus that has these data, that have had these data for a long time. Now maybe there can be some more back and forth between those kinds of things, simply expanding on this particular technology. But the notion of big data in other disciplines is something that is applicable certainly beyond archaeology.
Mary, go ahead.
Yeah, hi. Thank you so much for hosting this and for the talk, Marcello.
You're welcome.
So I have a question. So I think in regards to big data, I think oftentimes this gets confused for sort of this like all or a sort of, I don't want to say like gluttonous, but like a sort of an all-consuming data approach. And so I'm wondering if you might be able to kind of clarify this to more of how you sort of see this as more of a smart data approach to acquisition of big data, and how this can maybe be tailored to grad students or early career students and scholars, particularly given the fact that there are you know, certain types of funding opportunities and you know, certain budgets that maybe graduate students might be dealing with when approaching perhaps LiDAR budgets,
Right.
As well as postdocs and these sorts of things.
Sure, and that goes to the point that this is an expensive technology, right? And it's not something that's accessible in ways that perhaps other data have been. There is always a sequence in any kind of satellite data now is Googleable, but it wasn't Googleable even 20 or 30 years ago. It was a state secret, it seemed like, and it was highly guarded. So I hope that we're in a process like that where eventually this becomes a public access, so there isn't that concern. Eventually, I think, just in terms of the question of the simple question, the pragmatic question of access, I think that the sort of LiDAR the planet kind of concerns will eventually win out, and this will happen in certain places in Europe and so forth. That's happening already, right? and what's it's sort of odd about this is that LiDAR, that archaeology is just the most charismatic application of this technology, right? Because it has all of the elegant blah blah blah. But in other places, Europeans who've been working with LiDAR for a long time have, I think one of the Baltic states has LiDAR its entire national territory every 2 years, just because they want an updated record of the land use record from there. Now it's a small country relative, but they've just net and it's publicly available. So I think some of those questions I think will work themselves hopefully out in different ways. But that doesn't address some of the bigger questions that you're asking. What's important, I think, to think about is that, yes, I think some of this big data discussion may be involving like social media. Is that what you meant? Is that kind of right? One of the things to sort of think about is, to me, the data is something that we're actually, as archaeologists, actually developing, right? In other words, what is given is a topographic land terrain image. And then everything that's on top of that, all the structures and buildings and all the other things that we think about in archaeology are data that we are putting on there, right? So to a certain extent, it's not data that's just given to us, it's just there that can be used and misapplied. It has to be kind of digitized. And that's a huge question with regards to what can we see? Are we really seeing it? Does it have to be verified in the field and so forth? All these kinds of questions also come up. So to the extent that it isn't like a huge data dump that is just there for immediate analysis, it's there for digitization, which will render us blind by the time we're done, right? But it is, you're right, to the extent that what it opens up is a scale of analysis that was implausible. Until recently, right? What we then do with it is what our interests as scholars kind of lead us down to do with it, right? And there are some who immediately see this and want to study that, and voila, they can look at that, right? Alignments of buildings and so forth. There are those who want to look at something else, and that's what they'll actually look at. In the world of full accessibility, eventually all of these efforts and interests combined will create a data set that will be hopefully more, a large set of information that people can use and then discuss and then debate over whether it's well done or not and so forth. Well, that will never end. But we're sort of in that raw stage of, okay, we have now the ability to do it. Now it's a question of collecting that, and then what do we do with it, and how do we share it, right? And that's the part that is sort of I think we're flying blind in the Maya world, especially. Other parts of the world are very much more advanced with regards to this than we are. And that's because we are in this bizarre position, this complicated position of being scholars in countries that that have not yet dedicated their resources to doing this themselves, and have this awkward, to be kind to us about it, position with regards to how these data are being distributed and collected. I think that there's a catching up to be done with regards to this, and perhaps a digital standards of digital data that will have to be established to make use of this in long term, right? How do we operate, a code of ethics with regards to this kind of stuff. Right now it's ownable, and that's sort of an odd thing, frankly. Those are, I don't know if I have addressed some of your questions, Mary. Does that get at what some of the things you were thinking about?
Absolutely, yes. And, I think even sort of touching on things that I could probably have 100 conversations about.
Yeah, exactly.
Like opening up interdisciplinarity and then collaboration. Yeah,
exactly.
Absolutely.
And as I said, in this case, archaeology usually is the sitting at the kiddie table, getting the scraps of the scientific research end of things, because some NASA program has decided to do this, and all of a sudden it happens to have this archaeological application. Now LiDAR, in this case, or this data collection, is being driven by archaeology really for the first time in many respects, and that's peculiar, right? Because obviously, if I were a minister in Guatemala, Belize, Mexico, and whatnot, I would want to have that data in my country and managed by my government as a case of even security, right? National security. That isn't happening yet, and perhaps that will over time. It's already you can see that it's starting to catch up in terms of local policies. But that's where we are. It's kind of this wild west of new data not being under the, I grew up in New York City, and all my high school friends went to work on Wall Street, and one of them said, well, derivatives, when the derivative market went nutballs and everyone lost their shirts, well, there were no laws about it, so it wasn't illegal. It doesn't mean that it wasn't right, but and then they regulated it, and hopefully it won't happen again. But that's sort of what I feel like a little bit, is that it's a not regulated world yet, and so it's one of those things that it needs that for future research, or for future sort of form of ethical use of data.
It's striking to me, listening to you talk today, Marcello, just how much archaeology, or at least Mesoamerican archaeology, is in the middle of a paradigm shift, right? Where all of a sudden, many truths that we thought we, held to be self-evident have been radically changed by new data. And then the sort of relative hierarchy of different kinds of data gathering, and then the questions of what are the ethics that you set up around data, are all really in flux in this moment and still being negotiated.
Yeah, you are. I will add one other element to it, which is something that has always been true, but has never been practiced. And I'm the son of two physicists, so I thought about science a lot in my life. And one of the things that is clear in almost all what the true sciences, as it were, is replicability, right? Someone can replicate someone else's result. And this is where this can happen, right? For the first time, really. You could always replicate someone else's mapping, but it was not practical, and it was almost impossible to do that. And the few times that a little bit of overlap occurred, there were these undoing and kind of concerning differences between how what one person mapped and what another person mapped, but whatever. But replicability is something that is now plausible, in the sense that I can sit with these data for a year, say that I think I see this, pass it on to somebody else, and they can start with it afresh, and do they replicate what I did, right? So that's just one sort of at a very basic level. But then, yes, what do these data tell us, right? Now, there are debates, and there'll continue to be debates about the extent that what we are seeing is any different from what has been said, or actually confirms how people have what one camp says versus what another camp says. So I don't think it will resolve anything. It will probably change the shift. It'll shift certain paradigms to the more likely, and the other paradigms will have to be explained more, right? That's how I think of it. Certain things will have to be explained. Like, we know that there are these phenomena out there. If you want to maintain a paradigm that doesn't really fit with those, you'll have to explain yourself a little bit more. That's how I feel. And yeah, I think that it's one of those questions where the data will, I hope, yes, and as you said, the access to it is something that, how do I put this? It was always the case, right? But the data access to a project it was always highly controlled matter, where you hear these stories. Oh, so-and-so was hoarding data for 20, 30 years, whatever. But it was of a patch this size, right, relative to the rest of the region. Now you're hoarding data over a patch that's 100,000 times. Now it becomes a little bit more uncomfortable to say, hey, are you going to do all of that? Is that you're going to analyze it all forever and ever? So it's I remember receiving someone's notebooks and notes from the field as a donation to the Institute years ago, right? And it was sort of a highly guarded secret that was kept at this person's office for 30 years. And finally it was, oh, great, now people can see what this person was talking about with X, Y, and Z, right? But at least it was a small little corner a small little corner of a small little corner. Now that small little corner is kind of like half the room of a big house. So it starts becoming a little uncomfortable because what are you going to do with all that space? Are you really going to use it all? So yeah, those are some of the questions that I think long-term are going to have to be dealt with. Yeah.
Marcello, thank you so
You're
much.
welcome. I hope people
It's
enjoyed it.
been really fascinating to think about how everything is changing in this moment, and with these and with, you know, and all the ethical quandaries, and how much things are going to continue to change.